everyone, I am Madhu. So friends, today we are going to discuss about chapter number 7 of class 9 maths, which is triangles. So in this chapter, basically we are discussing about the congruency of a triangle. When two triangles are congruent. What is congruency? About this topic we will discuss later on. So in this video, first of all, we will discuss all the congruence rules. There are total 5 congruence rules. We will discuss about them one by one, and then we will discuss some rules and theorems that are given in the chapter, and then we will do some questions, 4 to 5 questions. So let's start with our first topic, which is congruence rules. So friends, now let's start with the congruence rules of a triangle when two triangles are congruent. So what is the meaning of word congruence? Congruence means that when two figures are having same size and same shape, then both the figures will be congruent. They are having same size and same shape, then they will be congruent. So here we are talking about the congruence of triangles. So there are total 5 criteria for congruence of triangles, criteria, or you can say rules. So the first criteria is SAS. So what is the full form of this? Side, angle, side. When in two triangles, two sides and one included angle are equal, then both the triangles will be congruent. Two sides. Let's say for example, in this triangle, side A and side B. And in that triangle, side E and side F. If they are equal in both the triangles and one included angle. Let's say this included angle. So this is the only angle which is included in both these sides A and B, and in this triangle E and F. So if these both sides and this included angle are equal in both the triangles, these triangles will be congruent. So this is the first criteria for the congruence of triangles. Second criteria is ASA. The full form is angle, side, angle. When in two triangles, two angles and one included side is equal, then also the both triangles will be congruent. Two angles, let's say for example these two angles in both the triangles and the included side, means these both angles and the included side will be side B. So if these both angles and this side are equal in both the triangles, then also the triangles will be congruent. Third criteria is AAS, means angle, angle, side. Means any two angles and one side are equal in both the triangles, then also they will be congruent. Any two angles and any side, it can be A, B or C, then also the triangles will be congruent if they are equal in both the triangles. This is the third criteria. Fourth criteria is SSS. The full form is side, side, side. Means if all the three sides are equal in both the triangles, then also the triangles will be congruent. All the three sides, if they are also equal, then also the triangles will be congruent. Then the fifth criteria is RHS. For RHS, the full form of RHS is right angle, hypotenuse side. Right angle, hypotenuse. Hypotenuse is the side which is in front of the right angle. Hypotenuse side. So this is the full form, right angle, hypotenuse. Hypotenuse is the side which is in front of a right angle and side. So for RHS criteria, we need a right angle triangle. So friends, I have drawn here two right angle triangles. So right angle triangles are those triangles which are having 90-degree angle in them. So we were talking about our fifth criteria for the congruence of triangles, which is RHS, right angle, hypotenuse side. So if there are two right angle triangles and there is a 90-degree angle in them, here in this triangle, this one is the 90-degree angle, and in this triangle, this one is the 90-degree angle. So if there is 90-degree angle in both the triangles and hypotenuse is the side in front of the right angle. So here is the right angle, 90-degree angle, and the side in front of it is C, side C. So this is the hypotenuse. In this triangle, G, side G is the hypotenuse. So if there is right angle in both the triangles and hypotenuse in both the triangles are equal and any one side, means that side can be side A or side B. In this triangle, the side can be side E or side F. So a right angle, hypotenuse, and any one side, if it is equal in both the triangles, then also both triangles will be congruent. So these were the 5 criterias for the congruence of two triangles. Now let's discuss some rules and theorems that are there in the chapter, and then we will do some questions. So friends, now let's discuss about some rules and theorems that are discussed in the chapter. So first one is angles opposite to equal sides of an isosceles triangle are equal. What is an isosceles triangle? Isosceles triangle is a triangle which is having two sides equal. There are 3 sides in a triangle and 2 sides are equal. Then that triangle is isosceles triangle. So angles opposite to the equal side means if this is one isosceles triangle and let's say that these both sides are equal. So the angles opposite to the equal side means this angle and this angle, which is opposite to this equal side, and this angle is opposite to this equal side. So these both angles will be also equal, means angles opposite to the equal sides, they are also equal. Second is the sides opposite to equal angles of a triangle are equal. This is also one of the same thing, just it is written in a reversed manner. What it is saying, that angles opposite, side opposite to equal angles. If these both angles are equal, then the sides opposite to them. So the side opposite to this angle will be this side, and the side opposite to this angle will be this side. These both sides will be equal if these two angles are equal. So the sides opposite to the equal angles, opposite to these both equal angles, they will be equal. It is also one of the same thing as I have said in the first rule, just it is written in a reversed manner. Third one is if two sides of a triangle are unequal. If there is a triangle and two sides are unequal, the angle opposite to the longer side is larger. So what this one is saying, that if there is a triangle, let's say this triangle, this side is A, this side is B, and this side is C. So what it is saying, that if two sides of a triangle are unequal, any two sides are unequal, the angle opposite to the longer side. So which is the longest side in this triangle? It is side A. You can observe that in this triangle the longest side is side A. So the angle opposite to the longer side, which is the angle opposite to side A? This angle. You can observe that this is the angle opposite to the side of side A. So this angle is larger, means angle opposite to the longer side. Angle opposite to the longer side is this one, and it is the largest angle in the triangle. So the angle opposite to the longest side of a triangle is largest. Then fourth one is in any triangle the side opposite to the larger angle is longer. Here also it is one of the same thing, just it is written in a reversed manner, that side opposite to the largest angle in the triangle, that side is longest. So here you can see the largest angle is this angle, and the side opposite to this angle is side A, and you can see that side A is the longest side in this triangle. So it is also one of the same thing. Fifth one is the sum of any two sides of a triangle is greater than the third side. So let's say this side is, we will take this triangle, this side is 8 centimeter, this side is 3 centimeter, and this side is 6 centimeter. So it is saying that sum of any two sides. So sum of any two sides, we can add any two sides. The sum of any two sides of a triangle is greater than the third side. Means if we will add any two sides of the triangle, the sum which we will get, it will be greater than the third side. So we will add any two sides. For example, we will add 8 plus 3. 8 plus 3 is 11. 11 is greater than the third side, which is 6 centimeter. Let's add 6 plus 3. 6 plus 3 is 9 centimeter. It is also greater than the third side, which is 8 centimeter. Fine. So these were the 5 rules that are there in the chapter. So friends, here I forget to tell you about one topic, which was CPCT. The full form of CPCT is corresponding parts of congruent triangles. Means if there are two congruent triangles, there are two triangles and they are congruent. So the corresponding parts means the rest of the parts of those triangles will be also equal. If there are two triangles and they are already congruent, so the corresponding parts means the leftover or the rest of the parts will be also equal. So this is CPCT, represented by CPCT, corresponding parts of congruent triangles. So friends, till now we have discussed all the rules, all the criteria for the congruence of two triangles, and every topic we have discussed. Now let's do some questions. So friends, let's do some questions. So the first question is, in quadrilateral ABCD. So here in the figure we are having one quadrilateral which is ABCD. So it is a quadrilateral as it is having 4 sides. Then in the quadrilateral ABCD, AC is equal to AD. AC is equal to AD. I have marked these both sides are equal. Then and AB bisects angle A. AB, you can see this line segment, it is bisecting this angle A. What is the meaning of bisecting? What is the meaning of bisect? Means this line segment is intersecting or dividing this angle into half. So we can say that this angle A is equal on both the sides of the line segment AB. Bisecting means dividing the angle into half. So AB bisects angle A. So this line segment AB is bisecting this angle A. Show that triangle ABC, this triangle is congruent. This is the sign of congruent, equal and then that curve dash. So it is a sign of congruent. Triangle ABC is congruent to triangle ABD. So what we have to prove, that this triangle ABC is congruent to triangle ABD. So we have to prove them both congruent. Then what can you say about BC and BD? So this also they are asking that what we can say about, what we can conclude about BC and BD, these both line segments. So first what we are going to do, first we are going to prove these both triangles congruent, and then we will write about BC and BD. So let's start. So how we are going to start is, first of all we will write in triangle ABC and triangle ABD. So we are talking about these both triangles. So in these both triangles, it is given in the question that AC is equal to AD. AC, which is the part of this triangle ABC, and AD, which is the part of the triangle ABD. So these both sides are equal in both the triangles. So we can write AC, we can write here directly AC is equal to AD. And in the bracket we have to write the reason as well. The reason will be, it is given in the question that these both sides are equal. So we are going to write given, as it is given in the question. Then for proving the congruency of a triangle, to prove these both triangles they are congruent, we need 3 conditions. One we have got, one side we got. Now we need 2 more. So what you can see that it is given in the question that AB bisects angle A. This line segment AB is bisecting the angle A. Bisecting the angle A means this angle A is equal on this side as well and equal on this side as well. So what we can write? We can write that angle BAC means this angle, this part, angle BAC is equal to angle BAD, this part. So we can write is equal to angle BAD. And what we will write the reason? Reason we will write, it is given, because it is given to us that AB line segment is bisecting this angle. If it is bisecting one angle, then both the angles, the parts of those angles will be equal. So the reason we are going to write is given. Then now 2 conditions we have got, one side we got and one angle we got equal. For proving these both triangles congruent, we need one more condition here. So now you have to observe the figure, that what can you think of that they are similar in both the triangles. You can see that, if you can notice that that AB line segment, this line segment AB is common in both the triangles. This AB is common in this triangle as well and in this triangle as well. So what we can write, AB is equal to AB, and what the reason we are going to write, it is common, because it is common in both the triangles. So reason is common because they are common. So we got three conditions, two sides and one angle. So these both triangles are congruent. So hence we can write that angle ABC is congruent to triangle ABD. In the bracket we have to write that by which rule they are congruent. So by which rule they are congruent? We got two sides and one angle. Two sides and one angle. So they are congruent by SAS congruence rule. So in the bracket we are going to write SAS congruence rule. So this is the reason for their congruency. So we have proved these both triangles are congruent. Now what the question is asking, what can you say about BC and BD? Means this and this. What can you say about them? So we have proved that these both triangles are congruent. So we can write. So hence we can write. We will write them equal by CP/CT. So we can write that BC is equal to BD. And what will be the reason? I have discussed just earlier. Just now I have discussed what about CP/CT. CP/CT was corresponding parts of congruent triangles. When we have proved that these both triangles are congruent, then the corresponding parts will be also equal. So hence we can write that BC is equal to BD, and in the bracket we can write by CP/CT. CP/CT, corresponding parts of congruent triangles. So this was the reason. Fine, so this was all about the first question. Now let's move on towards our next question. So friends, now let's discuss about our next question. It is AB is a line segment and P is the midpoint. So you can see in the figure that AB here it is a line segment and P is the midpoint. Midpoint means in the middle of the line segment. Then D and E are points on the same side of AB such that angle BAD is equal to angle ABE. So what they are saying that angle point D and E. So here are the points D and E. They are on the same side of the line segment AB, on the upper side. Then and the same side of AB such that angle BAD. Where is angle BAD? BAD means this angle. It is equal to ABE. ABE, this angle means this angle and this angle are equal, as you can see in the figure. Then and angle EPA is equal to angle DPB. Angle EPA, this angle is equal to angle DPB. DPB, this angle. So they are saying that P is the midpoint, and if P is the midpoint, it means that this distance and this distance will be same. And then they are saying that this angle and this angle are equal, and then they are saying that this angle and this angle are equal. So what we have to show that we have two parts in this question. First part is triangle DAP is congruent to triangle EBP. So we have to show that DAP, this triangle, this one triangle, this which I have marked in blue completely. So this triangle is congruent to EBP. EBP means this triangle. So we have to prove them congruent, this one and this one. And the second part is we have to prove AD is equal to BE. AD, where is AD? AD, this line segment, and BE and this line segment. So we have to prove them equal. So first what we are going to do, first we will prove these both triangles congruent and then we will prove them equal. So for proving them congruent, we will start the solution from here. In triangle DAP and triangle EBP, so we have to find three things equal in both the triangles so that we can prove them congruent by any criteria. So we need three things. So we can see in the question that they are saying that P is the midpoint. So if P is the midpoint, this distance and this distance and this distance will be equal. So you can see that this is the base of the triangle DAP and this is the base of the triangle EBP. So we can write from here that PA is equal to PB. Why? In the bracket we are going to write the reason given, because it is given to us that P is the midpoint, and if P is the midpoint, the distance will be equal. They will be equal. So one condition we have got, one side we have got. We need two more conditions for proving them congruent. So now let's see what they are saying. That they are saying that angle BAD is equal to angle ABE. BAD means this angle. It is equal to ABE, means this angle. So they are coming in both different triangles. So we can write that angle BAD is equal to angle ABE, and it is also given in the question. So reason will be given. Reason will be given because it is given to us that these both angles are equal. So now two conditions we have got. One more condition we need for proving them congruent. So what can you think of? You can think of one side we have got, one angle we have got. Now they are saying in the question that angle EPA and it is equal to angle DPB. So EPA means this angle and it is equal to this angle. But we are not talking about these angles. We are talking about the complete one. So you can see here, you can see if we are talking about the triangle DAP, we need this complete angle. Yeah, we need this complete angle. We do not need this one. So we are not having this portion. We are not having this portion. So this portion we are not having, and this we need, because they are saying this and this is equal, but the middle portion is not given to us, which is coming in both the triangles. So what we can do? We can add this middle portion, and this middle portion will be angle EPD. So what we are going to do is we are going to add the angles. So we are going to add the angle EPD in both the triangles. So we are going to write here the statement on adding angle AEPD, angle EPD on both sides. Why on both sides? Because why we are adding this angle on both sides? Because if we talk about this and if we talk about this triangle DAP, then we require this much more, so we have to add. So this is coming in this triangle also, EBP. This angle EPD is also coming in the triangle EBP. So we have to add in both the triangles. So after adding, here space have finished, so I am rubbing them all. So friends, we were adding this angle in both the triangles, so we will add them. So it will be angle, it is angle EPA. So angle EPA plus angle, which angle we are adding? EPD. So we are going to write EPD is equal to angle DPB in this angle. DPB plus which angle we are adding? EPD. Angle EPD. So after adding, if we are adding in both the triangles, so if these both angles are equal, it is given in the question that these both angles are equal. It is given in the figure. So if these both are equal and we are adding same thing in them, same angle we are adding in both the triangles, so the result will not change and they will remain equal, because we are adding same thing in both the things. So we are adding same angle in both the triangles, so the result will not change and these angles will remain equal. So what we can write? So when we will add the triangle EPD in EPA, so this is EPA, this part, and this is EPD. So what we are going to get? This complete angle. So this complete angle is DPA. So we are going to write it angle DPA. Angle DPA is equal to. So when we will add angle DPB and EPD, what we are going to get? This complete portion we will add in this one. So we are going to get EPB. 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 So we got this result, and we have written this equal, and in the bracket we will give the reason. We will write here just proved. Just proved. Now only we have proved that when we will add, these both angles were equal, and we have added same angle in both of them, so they will also remain equal. So we will write the reason just proved. So we have got three conditions. What conditions we have got equal? We have got this angle equal, this angle equal, this complete angle equal, and this third side. So they are congruent by which criteria? They are congruent by ASA criteria, because we have got this angle, we have got this angle, and the side including them, this side in both the triangles. So we can write, therefore triangle DAP is congruent to the triangle EBP. And in the bracket we are going to write the rule, which is ASA, angle side angle. Angle side angle congruence rule. So this was the rule by which they were congruent. So this was the first part. Now we have proved both these angles are congruent. Second part is saying that AD is equal to BE. AD is this line segment and BE is this line segment, and they are the parts of the triangles which we have proved here congruent. So what we can write, that AD is equal to BE by CPCT, corresponding parts of congruent triangles. So here we can write that second part I am doing here, AD is equal to BE, and in the bracket we will write the reason by CPCT. So they are also equal. So this was all about this question. Now let's move on towards our next question. So friends, here is our next question. It is, ABC is an isosceles triangle in which altitudes BE and CF are drawn to equal sides AC and AB. So as you can see in the figure that this is a isosceles triangle. Isosceles triangle is a triangle which is having two sides equal. That is a isosceles triangle. So in this isosceles triangle ABC, there are two altitudes BE and CF. So BE this altitude and CF this altitude. There are two altitudes and they are drawn to equal sides AC and AB. So in an isosceles triangle there are two equal sides, and in this isosceles triangle the equal sides are AB and AC. Fine. So here, now altitudes are drawn from this. So this is the side AB, and from this AB side BE altitude has been drawn. And from the side AC, which altitude has been drawn? This CF altitude. So from the both equal sides there is one altitude. Then show that these altitudes are equal. So the question is asking that we have to show that these both altitudes BE and CF, they are equal. So what we have to actually do in this question, we have to prove these two triangles congruent. Because when we will prove these two triangles congruent, which triangles? ABE and AFC. These both triangles, this one, this portion, this triangle and this triangle. So we need to prove them congruent, because when we will prove them congruent, then automatically by CPCT, corresponding parts of congruent triangles, the altitudes will be also equal. So first we have to prove them congruent. So friends, let's begin with the solution. So how we are going to start is, first of all we will write that in the triangle, in both the triangles which we are talking about, of which triangles we are talking about, ABE, triangle ABE, and the triangle ACF. So we are talking about these both triangles ABE and ACF. So now we have to find three conditions, or you can say three things in which they both triangles are equal, so that we can prove them congruent by any criteria. So it is told in the question that the equal sides, it is a isosceles triangle. So if it is a isosceles triangle, so two sides of the triangle will be equal, and the two sides which are equal, they are AC and AB. So these both sides are equal, and they are coming in these different triangles, in these both triangles. So we can write AB is equal to AC, and in the bracket the reason it is given to us in the question that the equal sides of this triangle, of this isosceles triangle, are AB and AC. So we can write AB is equal to AC. Now we need two more conditions here. So what you can observe in this question, you can see that in both these triangles angle A is common. So you can see that angle A is coming in this triangle also and in this also. So we can write angle BAE. Angle BAE is equal to angle CAF. And this also in the bracket, the reason which we will write, it will be common, because this angle is common in both the triangles. You can see that this angle A, it is common in both the triangles. So we can write angle BAE is equal to CAF, and the reason will be it is a common angle. Then one more condition we need here to prove them congruent. So what it can be? Now you can see here that the BE and CF, these line segment BE and CF, they are the altitudes, and altitudes always form a 90-degree angle. They are always perpendicular to the side. So here there will be a 90-degree angle. Here you can see, here also it is a 90-degree angle. So here also it will be a 90-degree angle, because they are the altitudes. Here also there will be a 90-degree angle. So what we can write is angle, which angle it is in this triangle? This angle is it is BEA is equal to angle CFA, and in the bracket reason what we will write? We will write 90-degree each, because they are 90-degree angles. They both are 90-degree angles because they are forming on a altitude. The altitude BE and the altitude CF are forming these 90-degree angles. So they both are of 90-degree each. So we got three conditions, one side and two angles. So hence we can write that angle ABE and angle ACF are congruent. So we can write therefore angle ABE is congruent to triangle ACF. And what will be the reason? By which criteria? It will be angle side, because there are two angle and one side. So we will write the reason in bracket, angle side, congruence rule. So they are congruent. We have proved them both congruent. But the question is asking that show that these altitudes are equal. The question is actually saying that we have to prove the altitudes equal, which are the altitudes BE and CF. So how they will be equal? Just now we have proved that these both triangles are equal, and you can see that in both these triangles the side BE and CF are there. So you can see BE, we were talking about this triangle, so here it is a side BE, and you can see we were talking about this triangle, so here is the side CF. So if we have proved these both triangles congruent, then the side BE and CF will be also equal, and BE and CF were our altitudes. So hence we can write that BE, I am writing it here, BE is equal to CF, and in the bracket the reason which we are going to give is it will be by CPCT. So hence this was the question. We have proved all the things, we have proved them congruent, and then we have proved that the altitudes are equal by CPCT. So this was all about this question. So now let's move on towards our last question. So friends, here is our last question. It is, AD is an altitude of an isosceles triangle ABC. So here I have drawn the figure. There is an isosceles triangle ABC in which two sides are equal, and AD is the altitude. AD, this line segment is the altitude of this triangle, and they are saying that in which AB is equal to AC. So as you know, in isosceles triangle two sides are equal. So they are saying AB is equal to AC, means this side and this side, they are equal. These both sides are equal. Show that first part is AD bisects BC. So we have to show that this altitude of the triangle AD is the altitude, it is bisecting BC, this line segment. What is the meaning of bisecting? I have told you earlier also. Bisect means dividing that line segment or that side or that angle into half. So we have to prove that this AD altitude is dividing this BC line segment into half. So basically what we have to prove is that this distance and this distance is equal. So for proving this, what we have to do, we have to prove these both triangles congruent, because when we will prove these both triangles congruent, automatically BD will be equal to DC. These both line segments, the half of this, it will be equal. So first of all, we need to prove these both triangles congruent. Then we will do the rest of the parts. So for proving these both triangles congruent, what we have to do, we will start the solution from here. In triangle, about which triangle we are talking about? ADB, triangle ADB and triangle ADC and the triangle ADC. So about these both triangles we are talking about. So first of all, you can see that AD, this line segment, this altitude, this is the altitude, it is having 90-degree angle on both sides, because I have told you earlier also that altitude always form 90-degree angle. It is always perpendicular. So here the both triangles are having 90-degree angle. So hence what we can write, that angle ADB is equal to angle ADC, and in the bracket what will be the reason for this? It will be because they are forming 90-degree angle each. You can write each angle of 90 degree. Each angle is of 90 degree because they are forming on the altitude. So for proving these both triangles congruent, we need three conditions. One we have got. What will be the another one? So you can see that it was given us in the question that AB and AC are equal. It was given to us that these both sides are equal, and hence we can write that AB is equal to AC. And what will be the reason for this? It will be because it is given to us in the question. So it is given to us that these both sides are equal, that's why we have written AB is equal to AC. So now here we have got two conditions. Now we need one more condition for proving them congruent. So what it can be? You can see, and now I have just proved here that AB is equal to AC. So this is the side in front of the right angle. As I have told you that the fifth criteria for the congruence of two triangles, it was RHS, right angle hypotenuse side. So you can see here that the side in front of the right angle. So you can see here this is the right angle, 90-degree angle, and the side in front of the right angle, it is known as hypotenuse. And you can see that hypotenuse is equal in both the triangles. So one right angle is equal in both the triangle, and hypotenuse is also equal in both the triangles. So by which criteria they will be congruent? RHS. So now we need here one more condition. What it will be? You can see that this altitude AD, this is common in both the triangles. This is the common side AD. So we can write AD is equal to AD, and the reason will be it is the common side in both the triangles. So here we have got three conditions: one right angle, hypotenuse, and one side. So hence we can write that triangle ADB and triangle ADC are congruent. And by which congruence criteria? It will be RHS, right angle hypotenuse side. So hence we can write here that therefore triangle ADB is congruent to triangle ADC. And in the bracket there will be the congruence rule. By which congruence rule? It is RHS, right angle hypotenuse side. Fine. Now these both triangles we have proved them congruent. Now what we have to prove is that AD bisects BC and AD bisects angle A. So what we have to prove is that this AD altitude is bisecting this line segment BC and this AD altitude is bisecting this angle A. So just now we have proved that these both triangles are congruent, and you can see that these half of the line segment DB and DC, they are the part of the triangles which we have proved congruent, and this angle as well. So what we can write that AD bisects BC and AD bisects angle A, they are by CP CT. So the altitude AD is bisecting the line segment BC by CP/CT, corresponding parts of congruent triangles, and angle A as well. So this was all about this question. I hope you have understood it and found this video helpful. So friends, we have finished this chapter, which was chapter number 7, triangles. So friends, I will be coming back with some more new topics of class 8 and class 9. Till then, that's it. And if you find our videos helpful and informative, subscribe to our channel and press the bell icon and share it with your friends. So that's all for this video. Thank you.